Hello, my name is Teresa. I go to Palo Alto High School, and this is my final milestone. So this is an interactive pet planter, and as you can see, there's a pot, so you can like put a plant in here, and then it will tell you when there are critical levels of moisture and temperature. Uh, Let me just get this connected. It takes a little bit. So I chose this project because I like plants and I like the design of this planter. It's very sleek, it's very compact.
Water is getting low. I'm thirsty.
Okay, that's the warning that it gives when the moisture is too low. So, which is in this case about 350. 350 is the low limit and 500 is the high limit. So if I put in this damp towel, the sensor inside the pot will cause the moisture level to go up. It may take a little bit of time.
That's too much water. Help me before I drown.
Okay, that's the exceeding limit audio warning. I'm just going to keep this here so it doesn't keep telling me that. Okay, so as I previously said, there is a sensor inside of this pot and it measures temperature, it measures moisture, and this is a capacitive soil sensor, which means that there is a material inside of the sensor, and when water comes into contact with it, it will cause the capacitance, which is the ability of the material to store charge, that will go up, and that is detectable in regards to the moisture. And it's connected.
That's too much water. Help me before I drown.
Okay. It's connected to the Pi portal, which contains the main processing units. That's where all the command processing happens. And the sensor Pi portal, these two communicate through I2C protocol, which is a kind of serial communication. Basically, they continuously send each other 8-bit data frames, which are like data packets, and they will send acknowledge messages in response to each other. And this planter runs on CircuitPython, which is basically a type of Python. And in regards to the planter itself, it basically just sets up the graphics. So for example, you can see the pixels, like this root image, the temperature, the humidity, those are all set up in CircuitPython. And so is the animation. Basically, there's like percentage and value, and depending on the percentage and value, the pixels will automatically go up or go down. Now, the part of my milestone which I worked on was connecting this to Wi-Fi, and the way that code works is it gets the SSID, which is the name of the Wi-Fi network, and its password, and then it'll continuously try to connect to the Wi-Fi. If it doesn't work, it'll just try again. It also pings Google, it pings it takes different URLs and tests them to see if it'll connect. If it connects, it'll display the message before the graphics load. And the way that the Wi-Fi works is essentially requests are converted into binary, which are then converted into radio waves. The router converts back into binary, and then it goes back and forth like that to establish a connection. So there were a lot of challenges I encountered while connecting this to Wi-Fi. The number one problem I had was faulty instructions, because the instructions are not very coherent and very repetitive. So it took a lot of effort to understand them, and eventually I had to ditch the instructions entirely because I realized that the planter did what I intended it to do. And since it's complete, that means that I can now move on to the modifications. One of the ideas I had was to set up different modes by coding the software to create different settings for limits of moisture for different plants.